Alright, so we're going to talk about the title's error, but we're going to start with figuring out what a hypothesis test is and then transition over into what error for a hypothesis test represents. So let's just jump in and look at that. A hypothesis test is a method that we used to determine if there's evidence to support or not support a particular conclusion. So it's the mechanics behind calculating a probability that a particular sample is rare enough that we actually think something interesting or statistically significant has happened. I like to think of hypothesis tests as sort of a why do we even bother to collect data? Um, I'm we collect data, you know, theoretically, because we think something's different. Kind of like why do people argue? Well, they argue because one person thinks the other person is wrong. Same sort of idea with hypothesis test. We collect data because we think something has changed and we would like to investigate whether that statement is true or not. And so this whole thing about hypothesis test is a sort of organized investigation, sort of an organized way to have an argument and come to some conclusion that either there was or is not a valid point to the beginning of the argument. Okay, so let's kind of talk about this statistically significant statement here. When we say something statistically significant, we're saying that the likelihood of that sample showing up is so rare that I don't think it was random. I think there was something else going on. Um, Again, our job is not to say what that something else is. It's simply to say, when we look at the data we collected, based on the overall impression of what we think should happen, would occur a certain percent of the time. And that's that percent, that probability, that p-value that we are using to determine whether or not the sample is evidence of something bigger going on. So statistically significant means it is not just due to random chance. Okay, so if it's not due to random chance, then what is it? And that's kind of what we're trying to look at. Um, so when we think of random chance or we think of something that's statistically significant, we like to sort of think about where in the data are we. We're already assuming that our data has sort of a symmetrical feel to it, that there's a central value we think most data values should be around, and that there's some extreme values that we think aren't very likely. So the stuff in the middle, we're not too impressed by. But the stuff at the ends, that's where we're going to stop and sort of think about if it's, if it's in the ends of the data, if it's in the extreme values of the data, then perhaps there's something interesting that might have occurred. And how likely or what percent of the time would that happen? So this hypothesis test process will give us a number, a probability, a p-value that we can then use to determine whether or not something interesting has happened. Okay, so when we start by setting up a hypothesis test, we're going to first think about what we're trying to investigate. We're going to think of that, if that thing that we're investigating isn't present, what would that mean? Okay, in other words, before we start an argument, we think something should be happening. So what's the initial position? What's our initial feeling as far as what that goes? Then we gather evidence against that particular assumption, and we see if there's evidence out there that suggests that maybe something has in fact changed. Okay, classic example is a murder trial. How does a murder trial actually work? Well, we first assume the person is innocent, and then we call witnesses up to testify to the guilt, and we listen to the evidence suggesting that the person is guilty. Okay. In hypothesis test, we do the same thing. We, for lack of a better saying, the data is innocent, but we assume that what we're interested about, the reason why we're gathering the data, didn't happen, and we try to look for enough evidence that maybe it actually did. Okay, so in doing this process, there are set steps that we're going to follow. Number one, we're going to check assumptions. Every data set, every data type has a list of things that function in order for that data type to work, and so we're going to check that those things are valid, and that again we'll go through that when we look at particular data types. Then we're going to define our hypothesis statement and the parameters of that hypothesis statement, meaning what are we trying to gather evidence for, and then what do all these variables physically represent in the problem. Then there's going to be some sort of calculation where we're actually going to work out some math and get a probability, a p-value. And then finally we're going to make a conclusion based on what the p-value actually told us. Okay, and the nice thing is that this process we've already seen with confidence intervals. There actually is a linkage, a connection between a confidence interval and a hypothesis statement. Sort of, they support each other interchangeably, and that's sort of another lesson we'll kind of get to, reviewing hypothesis statements and looking what it does. Okay, so how do we write a hypothesis statement? We start by setting up what's called a null hypothesis. The null hypothesis is the statement that we are claiming is being tested. It's the one that doesn't have the effect or doesn't have the assumption. In other words, that's if I don't gather evidence, this is what we're going to think is going on. And the notation for that is H sub 0, H naught, if you have some science terminology in you. Then the other statement is the alternative hypothesis, and this is the statement that we are trying to gather evidence on, or that we suspect has some merit to it. And we label that one as HA, or alternative hypothesis. Okay, so how do we write it? We start with our null, and our null is going to be, this is what we believe is going on. So it's some sort of parameter, so some sort of population, whether it's mean or proportion or other things that we'll look at later. And then what value do we think is going on? And then the alternative hypothesis comes in one of three directions. We either can have a greater than, so we think the data is going to support that the null is actually that the actual hypothesized value should be higher, or it could be less than, in which case we suspect that the parameter is actually lower than what we hypothesize, or maybe we don't even know. And so we do what's called a two-tailed test, and we take both into account. And again, we'll go through the mechanics on that. Okay. So when we perform a hypothesis test, we're doing it to make some sort of decision. It's kind of like when you have an argument. You argue to reach a conclusion of some point. You're trying to say either I'm right, or you're right, or maybe somewhere in between, some sort of compromise. In a statistics standpoint, we're going to do one of two things. We're either going to reject the null or fail to reject the null, which I happen to think is just great. In other words, if you think about a couple arguing, it's either I'm right or I did not find evidence that I am right, is sort of the other way to say it. But in a statistics sense, we're just going to stick with reject and fail to reject. And when we're doing these things, and this is where the error comes in, and I want to specify error does not mean someone made a mistake. It's that we make these decisions based on how rare something has occurred. So what's the probability of something like my sample actually showing up? And so when we make one of these decisions, there's actually a chance that maybe what I interpreted was rare as evidence against something. Maybe it just actually was rare. It's not really evidence. And so we're going to talk about sort of those types of decisions. And so when we make that decision, we could either reject or fail to reject. And so there's two types of error that basically go with each one of those. If I rejected it and I shouldn't have, or if I failed to reject and I should have. We start by talking about type 1. Type 1 is when I reject the null that is already true. In other words, I like to think of it as if I start an argument and I win. I get you to believe that I'm actually correct. Well, a type 1 error means I shouldn't have won. I set out to do what I was supposed to do, but the evidence really was rare rather than evidence, and I shouldn't have won the argument. So type 1 error for that. Symbolic, we denote it with alpha, and this is the same as our level of significance of the test. And graphically, what that means then is that's that percent of data that we say is interesting enough. Like if I say, you know what, if your sample is rare enough that it shows up 5% of the time, my alpha is 5%. So that's that level of significance that we get excited about as evidence that something's occurred. Okay, type 2 error is when we fail to reject the null when in fact it was false. Okay, so going back to the argument idea, if I try to start an argument because I think you're wrong, I gather evidence. Let's say I'm unsuccessful, and it turns out we conclude that you're right. Well, type 2 error means that I gathered evidence and it wasn't significant enough, but it should have been because it turns out I actually am right. Anyways, we refer to that as a type 2 error, when we fail to reject the null when in fact it is false. And we denote it with the letter beta, Greek letter beta. So the interesting thing is, with type 2 error, let's see, this assumes some we go out and gather evidence because I think that there's a mistake in there and I'm not successful, but I should have been, because it turns out in reality there was actually a difference. And so kind of go here. So going back to a picture, so if I'm up in the top curve, that'd be type 1 error. But type 2 is really based on this alternative hypothesis, this secondary graph that is actually what's going on in the real world, but I just don't know that yet. Hopefully this will make sense when we start putting numbers in here. Okay, so it's the sample statistic is really part of the HA curve, but we mistake it as being part of the null curve. Anyways, let me go back to my little chart. So let's talk about the types of decisions that we make with evidence and whether or not that evidence is, whether we made a good decision or whether there was some sort of error related to it. Okay, so suppose that we have a true null and we fail to reject it. What type of decision is that? So you kind of have to think about what that's trying to say. So go out and start an argument, and I try to gather evidence, and I don't reject the null because I have good evidence. That in fact is a good decision. So the null is true and we fail to reject it. That's good. That's what we should do. Okay. Suppose the null is false and we reject it. Okay, so in other words, the null statement doesn't have any value to us, not true at all, and we actually detect that and we reject it. That would also be a good decision. Okay. Suppose the null is true and we reject it. Okay, so the null is true, but evidence-wise, we say the null, we reject the null. That actually is not a good decision. Again, not something that it's not our fault, it's just based on how rare the data is. And that's what we refer to as a type 1 error, or alpha. And suppose the null is false and we fail to reject it. What type of decision was this? Well, a false null and we fail to reject it. So false meant I should have rejected it, but I didn't. So that's where type 2 comes in, and that's where we call it beta.